Hey stats class, I want to show you how to use a spreadsheet to help you with some of the 7.2 homework sets. So on this question, we're being asked to find a particular t-value that has a certain area to the right. So what we're going to use here is a built-in function in Sheets in Excel that is called t.inverse. Right? So I'm going to click t.inverse. It wants to know the probability. All right, that probability is not, this is the right tail, so we need to go to the left tail. So 1 minus 0.02, very similar to inverse normal. And my degrees of freedom, it's telling me what the degrees of freedom are, but that's 28. And we'll talk about what degrees of freedom are in some of your video notes. But degrees of freedom, when we actually do these confidence intervals, is just 1 minus, or your sample size minus 1. 1 less than your sample size. So there's my number. It tells me to round it to 3 places. So if I wanted to, I could click this and do the decrease decimal place button once, on that cell. And now it's 3 decimal places and rounded properly. So 2.154 is my critical t-value. All right, the next one, the same thing. Area in the right tail is 0.20 with 23 degrees of freedom. So if I did equals t.inverse, the probability, again, is 1 minus 0.20, and my degrees of freedom is 23. But there is that to 3 decimal places, 0.858. Now this next one says the area in the left of the t-value is 0.025. That is just t.inverse without any kind of manipulation. So I just put in the 0.025, comma, 7 degrees of freedom. Now it talks about using symmetry. And the reason is if you clicked on this and used the t tables, it gives you area to the right. So if you look at it, it says area in the right tail, and we're dealing with area in the left tail. So if I look for 0.025 in this table, there it is, and with 7 degrees of freedom, I would be right there. 7. There's that number. So it'd be positive 2.365. But that's in the right tail. Okay, but it's perfectly symmetric at 0, just like the standard normal distributions. There's a lot of crossover between the t distribution and the standard normal, but one of the big ones is zeros right there in the middle. So if this is positive, according to the table, positive 2.364, and this area in the right tail is 0.025, well, if the area in the left tail is 0.025, because of that symmetry, because I would fold over this line in the middle, then this number would be negative 2364, technically 65. I didn't round it correctly. But that's the idea. That's what they're talking about with symmetry. I don't need to use symmetry. I don't have to use the tables. So I can just use the t.inverse, round it to the number of places they tell me to, and it will attach that negative sign to it if I don't subtract the number from 1. So what I mean by that is I didn't subtract 0.025 from 1, so it threw me in the left tail. I made it a negative number. When I subtracted those numbers from 1 for part A and B, it adjusted and put me in the right tail. All right, critical values. So when it's talking about 99% confidence, what we have to remember is alpha, the area in these tails, is 1 minus the confidence level. So if my confidence level is 99%, that means alpha is 1% or 0.01. Now, in addition to that, for confidence, we have to divide this in half, because half of the area left over is in the lower tail and half is in the upper tail. So this is the number that I will use to find the critical value. That last thing you have to remember here is when you use t.inverse, your probability, if you pick this one, and it's perfectly fine too, if you pick that one and your degrees of freedom, it says it's 29 degrees of freedom, you just have to remember to take away the negative sign. So it wants me to round it to 3 places. So I'm going to adjust that down to where it only has 3 places after the decimal. But it's wanting the positive version of this. For confidence, you need both. You need the negative and the positive. But when you put it in here, you're only putting one number in, and they want you to use the positive version. So again, just take the